Okay, so in this little bundle of work, we are going to be extending the knowledge of forces and equilibrium that we practiced previously, um, and also extending it in a way where we are looking at considering systems that turn. So it's a different type of motion to the motion that we've considered so far, which has been horizontal motion, so it's moving in a horizontal plane, or vertical motion, moving in a vertical plane. With a moment, it's where something is turning about a pivot point. Okay, you may well have already met this in physics. So from our everyday experience, we know. So you should be able to visualize these types of things. Maybe not. If you've got a tight nut, then it's easier to undo it if you put a long spanner on it as opposed to a short spanner. So you're extending the distance from the nut that the force is being applied. You may recognize that if you've got a seesaw in a playground, you can balance it even if you've got two kids of different weight, different mass, and you do that by sitting the kids at different distances from the pivot point. So if a boy sits at one end of a seesaw, then he can be balanced by a heavier boy who isn't sitting so far away from the center where it's pivoted. And similarly, if you think of a door and where a door handle is positioned, the door handle is always positioned at the furthest point away from the hinges of the door. And if you try to close a door by pushing at the door closer to the hinges, then it's much harder to make that door turn than it is if you're acting at the handle. So there's a relationship between the distance a force is applied from a pivot point and the magnitude of the force that's being applied, and that's what's being described there. So in each of these examples, the application of the force is causing a body to rotate about an axis. So we've got rotational motion. Previously, only motion along a line has been considered. So as I said, we've considered things moving horizontally, we've considered things moving vertically. So these are all examples of moments. So the definition of a moment, the moment of a force about a point is found by multiplying the magnitude of the force by the perpendicular distance from the point. So you can see here in this example, we're turning about this point x. The force is acting P in that direction, so it's turning it in a clockwise direction. It's going to move in a circle in that clockwise direction, and a perpendicular distance of d from the center. So the way we calculate the moment of that force is by multiplying the magnitude of the force P by the perpendicular distance in meters. So P is measured in newtons and the distance is measured in meters. A force will have no moment about a point on its line of action as d is 0. So if we were applying at the point x, then P times 0 would give you a 0 moment. The force is measured in newtons and the distance in meters. The moment of the force is measured in Newton meters. So when we are giving units to our moments, Nm is the unit that we use. As we can see from this example, the way that force is being applied is going to have make that move in a clockwise direction. If we had another force acting in the opposite direction, a different distance away, then together they would combine to give a resultant moment. So it's important that we have a sense of rotation, that we have a positive direction, a positive moment, and a negative, in the same way as we were doing when we were resolving forces and we put a plus x and a plus y to say what sense of direction we were taking as positive. It's the same for a sense of rotation. Generally, I go with positive being clockwise. Doesn't matter, so long as you're consistent throughout the whole maths that you're doing on a particular system. And the moment of a force has both magnitude and direction, so it's a vector quantity. If you have a number of coplanar forces acting on a body, their moments at any point may be added, provided due regard is given to a sense of each moment, which is what I was explaining a minute or so ago when I was saying that that's going to turn entirely clockwise, but if you had another force acting differently in the opposite direction, then that would have a negative moment compared to that positive moment. And hopefully this will make more sense as we take a look at some examples.